Good morning, children. I hope all you are fine. Okay, today we are going to see the quadratic equation and how to examine the nature of roots in a quadratic equation. Already we have known the factorization of quadratic equation. To examine the nature of roots, we need to find out the discriminant value. In a quadratic equation, ax squared plus bx plus c is equal to 0 and a is not equal to 0. A is not equal to 0 means the coefficient of x squared should not be 0. Then b squared minus 4ac is called as discriminant and it is denoted by the letter d. That is, capital D is equal to b square minus 4ac. A is nothing but the coefficient of x squared. Make a note of it. A is nothing but the coefficient of x squared. B is nothing but the coefficient of x. C is the constant value in the quadratic equation. Next, to examine the nature of roots, we need not find out the solution for this. We can find out the types of the roots by using the discriminant. Whether the given equation has real or imaginary roots. Whether the equation has real or imaginary roots. If the roots are real, then it's a rational or irrational. Either it is equal or unequal. So, children, we have to find out the roots should be real or imaginary. If they are real, it's a rational or irrational, and then the roots are equal or unequal. For finding this, we are going to apply in the problem. So condition number 1, b square minus 4ac is positive. So if we apply the value of abc in the discriminant, if it is a positive, then automatically the roots are real and distinct. We can say the roots are real and distinct. If we get any positive value, then you can say the roots are real and distinct. When the value is a perfect square, then you can add one more word. The roots are real, rational and distinct. So perfect square in the sense we can say the example 9, 16, 25, 36, etc. So if we get the value perfect square, then the roots are real, rational and distinct. Suppose your b square minus 4ac value is not a perfect square, but it's a positive. If the number is 15, for an example, if the number is 27, then you can say the roots are real, irrational and distinct. This is the first condition. And second condition is, if b square minus 4ac is equal to 0, the roots are real and equal. It is very clear. It is not, how we can say, it's neither positive nor negative. Exactly, if you get the value of 0, then you can say the roots are real and equal. Third condition, if b square minus 4ac value is negative, if we get any negative value less than 0, minus 5, minus 10, minus 100, then we can say the roots are not real. In the sense we can say the roots are imaginary roots. This is the third condition. So we have seen 3 conditions, children. Note down it. If b square minus 4ac is positive, then the roots are real and distinct. If b square minus 4ac is equal to 0 exactly, then the roots are real and equal. If b square minus 4ac is negative, then the roots are not real. So now we are going to examine the roots of the given quadratic equation. I have given some examples to you. Now see in this problem, x squared minus 2x plus 5 equal to 0. Okay, right. Now what is a here? A is nothing but the coefficient of x squared. So a is equal to 1 now. And then what is b here? B is nothing but the coefficient of x. So it is minus 2. What is C here? I told you the constant value. So A is equal to 1, B is equal to minus 2, C is equal to 5. So now D is equal to B squared minus 4AC. You are going to apply the value. So B value is minus 2 the whole square minus 4 into straight away. For A, you can apply the value 1. For C, you can apply the value 5. So, minus 2 the whole square, we can get 4. Minus 4 into 1 into 5, we get the value minus 20 is equal to, we are getting minus 16. Now, see this. Minus 16 is a positive or negative value? Clearly, it is minus 16 is a negative value only. Since D is negative, the equation doesn't have the real roots. So you can write the roots are imaginary. Next example. 4x squared plus 4x plus 1 equal to 0. In this, what is A? The coefficient of x squared, that is 4. What is B here? The coefficient of x, that is 4. What is C? Here constant value is 1. So, now you can see this 4, 4, 1. For ABC, you have to apply this value to find out the discriminant value. So, D is equal to B square minus 4AC. If you apply the value for B, it is 4 and A for 4 and C for 1. So, 4 square you are getting 16 and if you multiply 4 fours are 16, we are getting the value 0. Since D is equal to 0, the roots are real and equal. In the next example, 2x squared plus x minus 3 equal to 0. In this, clearly you know that A is equal to 2, B is equal to 2, C is equal to minus 3. Straight away you apply the value of ABC. You are getting the discriminant as 28. It is very clear it's a positive value. And if it is a positive, I told you to check whether it's a perfect square or not. Clearly we know that 28 is not a perfect square. So now you can write the roots are irrational and distinct. Next example. A square b square y square plus 2abcy plus c square is equal to 0. In this, clearly they have given a is not equal to 0, b is not equal to 0. So, a value here, the coefficient of y square, that is a square b square is the a value. And the coefficient of y is nothing but it is 2abc. This is the value of b. And then here constant c is equal to c square. So now we know the value of a, b, c. Substitute in the equation d is equal to b square minus 4ac formula. If you substitute it, simplify it, you are getting the value of 0. Since discriminant value is equal to 0, then you can say the roots are real and equal. Next, we have seen 3 conditions today. First one I have told you, b square minus 4ac is positive, then the roots are real and distinct. Second condition I told you, b square minus 4ac is equal to 0, the roots are real and equal. Third condition I told you that b square minus 4ac is negative, then the roots are not real. So you can apply these 3 conditions. You find out the value. Automatically you can determine the nature of the roots for the following equations without solving it. Work out these sums. Come out with your doubts. Thank you, children. Be safe. Stay connected with us. Thank you all.